In this module, we will persist data locally, so we don't have to go to the server to fetch data every time. We'll use SQLite, not because it's the best storage medium, but because it's something I want to teach. I'll use the automated properties binding API to map objects to SQLite, which makes working with SQLite far easier. If I didn't have that API, I might have just skipped over SQLite altogether, as working with SQL is unpleasant and error-prone. In order to get the mapping right, I had to move some properties to getter and setters, as at the time I originally did this code, there was no option to exclude an entry from storage. This is no longer the case, and we can now mark a property for exclusion, but changing that would mean changing all the following modules, and that's not necessarily something I want to do right now. I used a local abstraction for all the persistence code to make it more domain specific, which is a good practice in general. App storage abstracts the process of saving the objects. So right now it's implemented using SQL map, but in theory we could replace that. Let's review this class. The class is implemented as a singleton and initialized on first use. Initialization creates the DB instance that is kept within the application. We create the SQL mapping instance to the database. Notice that the SQLite API doesn't have separate methods for create or open and does the former implicitly, which is pretty convenient. Next, we create the tables if they don't exist. We create blank object instances for the objects that we need. Then define the primary key field. I also set the column type for price to be double. This is no longer necessary, as newer versions of the SQL map API detect the double property and automatically set the right type. Create table literally issues a create statement. Notice that we don't support alter at this time, although this might be introduced in the future. Insert and update are pretty much direct wrappers to the built-in methods that handle the exceptions locally instead of propagating the IO exception from the SQLite API. The reason for the delete listener is that we want the dish list to automatically remove the dish when it's deleted by the edit form. This allows us to decouple that code and get an event from the underlying data model. We use the event dispatcher class to subscribe and fire an event here. This is a really convenient class when you are building an API. Delete serves pretty much the same purpose as update and insert, with the exception that it also fires the dispatch event appropriately. App settings is a special object, as there is only one of it. So when we issue a select query, we should never expect more than one entry. However, it's still a select query. By default, when we invoke the select method, if a property value isn't null, it's added to the where clause. Both name and tagline default to non-null values, and so we need to set them to null. Once that's done, we can just do the select query as usual. If there are no entries, we just invoke insert for a new settings object. Fetching the list of dishes is similar, but more standard as we return the full list of dishes. The main point of interest is the use of the name property to indicate the order by option for the select statement. Some dishes might not have an image within them as we create them, and here we force a placeholder image to prevent such a case. I would recommend that you always use that strategy and have a good looking placeholder image. Now that we have the basic persistence object in place, let's proceed to integration. But first, let's discuss a conceptual issue. Why do we need persistence to begin with? Technically, we shouldn't have a local database as all the data is in the server and local data is meaningless. In theory, we could enable working offline, but that's not a current goal and would create many complexities I want to avoid. There is only one goal for this code, and it's performance. Users and developers often conflate performance with something that has to do with bits and bytes, but it's really about decisions we make as developers. Do we go to the server or do we use local data? Do we cache? In this case, it can create a conflict between the local and remote database. We need to guard against that, obviously. But once data duplication exists, we open up a risk. This risk is worth it for this level of performance.